Thank you. We are going to learn 3 theorems today, and those theorems are going to help us solve for missing pieces of mostly triangles. We are going to do a little bit with transversals, but mostly triangles. And that's a lot of this is going to involve algebra. So if you're an algebra kid, you're going to like today. All right, so the 3 theorems that we're going to learn, first is the side-splitting theorem. And I'm not sure that's like if you go to your professor in college and call this a side-splitting theorem, I'm not sure he'll know what you mean. I call it that because it's exactly what it is. So it helps people remember. But the side-splitting theorem says if you draw a parallel line through a triangle, so it doesn't have to be the mid-segment, it could be any line, so a parallel line there or a parallel line there, wherever, just parallel to one of the sides, it splits the other 2 sides proportionally. Okay, so for instance, if this side, if that's 5 inches to 1 inch, the other side would have to be in the same proportion. So it could be like 10 to 2, even though it doesn't look like it. Could be. Okay, but the pieces that the parallel line creates have to be in proportion. And then the corollary to that, and corollary just means, oh, also, by the way, this also works, kind of an add-on to the theorem, that even if you don't have a triangle, even if you just have 2 transversals, but you still have these 3 parallel lines, it also splits the transversal into proportional pieces. So like if this is 2 inches and that's 3 inches, this piece over here would have to be like 4 to 6. They'd be in proportion, in the same proportion. Even if they're different lengths, they'd be proportional to each other. Okay? And just like all of our alternate interior angle type theorems, the converse of the side-splitting theorem is also true. So if you draw a parallel line, the side-splitting theorem says if you draw a parallel line, then the pieces of the sides are proportional. The converse then would say if the pieces of the sides are proportional, that means this must be a parallel line. So again, the converse is proving parallel lines. Okay? So far, so good? Okay. All right, and the last one is the triangle angle bisector. We know all about angle bisectors, right? We've drawn them to draw incenters, and we've done a lot of work with constructing angle bisectors. If you draw an angle bisector in a triangle, the side that angle bisector intersects, it will cut it into 2 pieces that have the same proportion as the sides that are not split. Okay? So for instance, if this side is 4 feet long and this side is 3 feet long, and this whole side is 14 feet long, then this will split it into 8 and 6. Because these 2 pieces are going to have the same ratio as the 2 sides that weren't split. Let's apply these theorems. Okay, so first off, if I want to prove that MN is parallel to KL, what has to be true? What do we say up here? Right, exactly. Remember the converse of the side-splitting theorem says if the pieces of the sides are proportional, then the lines that made them are parallel. Good. So I just need to prove to verify that LK is parallel to NM. I just have to make sure that these pieces are in proportion. So what would my two ratios be? 15 over 30, good. And, I'm sorry? 21 over 42, good. Again, there's lots of ways you can do it. You can reduce the fractions, make sure they reduce to the same one. You can cross multiply. But 15 over 30 is 1/2. That's easy. And 21 over 42 is 1/2. So are they proportional? Yeah. So the pieces of the sides are proportional. That means the lines are parallel. Okay? All right. So now in this one, I've got, actually, it looks like a triangle, but it could also be two transversals that just happen to cross at A, right? Same thing. All right, so let's see if we can come up with the ratios here. So if AB is to DF the way AC is to, Anderson, what do you think? Right, good. EG. AE is to CG as what is to BF? So AE, CG, BF, and AD. Good. Okay, and last one, EG is to DF. So EG, DF, and CE and BD. Good. Does that make sense? Okay. So now let's solve for some missing pieces. So if we want EG, I want to set up a proportion. So I have to know one side of the proportion. I have to know both pieces. So is there anything in there that's already set up for me that I know both pieces of that? Yeah, 18 and 24, CE and BD, right? So 18 is to 24. Now I'm trying to set EG. So I'm going to call EG X, and it goes with the 18 side, right? And what should EG be set up? 10, right, DF. So I get 24X equals 180. Divide by 24, that's 7.5. Okay. All right, and how about AB? I need a ratio that I already know. So that'd be what, Eddie? The ratio that I need one side that has both pieces. So what would the ratio I already know be? First time we only had one choice, now we have two choices. Seven and a half to what? No? 10, right? Well, actually, AB, no, we can do 10 or 18. All right, so 7.5 is to 10, the way, and we're trying to solve for AB. So what's going to be up here for AB? 6 goes to X. Okay, cross multiply, I get 7.5 X equals 60. Oh gosh, was that 8? I get 8. All right, and finally AF. AF is this whole side, right? So let's call that X. So what would the proportion be for that? We know this is 7.5, right? So I need a proportion I know. I'm sorry? Say it one more time. Okay, 18 and 24. Okay, So if I'm trying to do this whole side, what would be this side? Well, add them all up. 6 plus 18 plus 7.5, which is 31 and a half. Over, and then we're trying to find x. Okay, cross multiply and solve, and I get 18x equals, what is that? I can't do that in my head. 31.5 times 24? 756. Okay, so x is 42. Yeah, 42. Okay. And we could check that, couldn't we? Yeah, so check it. What do we get? 42? Yeah. Yes. Uh-huh. Up here? Because the theorem says that this line cuts this in the same proportion as it would cut this. So to prove that they're parallel, I have to prove that the ratio of these two pieces is the same as the ratio of these two pieces. So 15 and 30, 21 and 42. Okay? All right? And last but not least, the side-splitting theorem. How would I solve for x here? Anybody have an idea? 12 over 16 should have the same proportion as, right? Good, right? The sides should have the same proportion as the side that, as the pieces of the side that the angle bisector cut apart. Does that make sense? Yeah? All right. So that gives me 12x plus 12 equals 16x minus 32. Subtract 12x, add 32, so that gives me 4x equals 44. So x is 11. So 11 minus 2 is 9, and 11 plus 1 is 12. So I can check that because 12 over 16 should have the same proportion as 9 over 12. So that's 3/4, and that's 3/4. So it works, right? Okay. All right, now let's try, you guys try these three. Same exact problems we just did, only I want you guys to do them.